Okay, paper November 2024, paper 3, variant 2. Question 1. Figure 1.1 shows the distance time graph for a student's journey. Student walks from his home to a shop. He stops at the shop. He then walks to his friend's house and stops there for 50 minutes. Okay. Then he walks back to his home without stopping. Okay. Determine the distance between the student's home and his friend's house. What is the distance between his home and his friend's house? Yes, it is 1,400 meters. From his home to his friend's house is 1,400. So this is at his friend's house, and this is at his home. Question I calculate the distance between the shop and the friend's house. Between the shop and the friend's house, yes, exactly. Started at 600, ended at 1,400, so the distance is 800 meters. Excellent. Calculate the total time for which the student is walking. The total time for which the student is walking. Do not include the time for which he is at rest. Can I find the total time for which he was walking? Can I do that? Yes, I can. Let's check out the graph. So if we check out the graph, we need to find any part with a slope. So for example, the first part you have 10 minutes. So you have 10 minutes while walking. And then he stopped for 10 minutes. Right? He stopped for 10 minutes. And then at this point, which was 35, he stopped. So from 20 to 35, he was walking. So from 0 to 10, walking. From 20 to 35, he was also walking. So this is again another 15 minutes. And then from, this is 85, right? This is 85 until 105. From 85 to 105, this is 20 minutes. So the total time for which he was walking was 10, 15, and 20, which is, yes, 45 minutes. So you need to add 10 plus 15 plus 20, which is a total of 45 minutes. Okay, now calculate the average speed of the student when he walks back to his home. Can I find the average speed when he walks back to home? Back home. How can I do that? Well, average speed equals total distance over total time. Total distance over... What was the total distance? Total distance was 1,400, right? We said that the total distance from his home to his friend's house was 1,400 meters. Yes, thank you. Total time taken while walking back is 20 minutes. Total time taken is what? Is 20 minutes. Why? Because we started at 85 and we ended at 105. So total time is 20 minutes. You have to convert the minutes into seconds. Yes, thank you. You have to convert the minutes into seconds. So speed equals distance over time. The total distance was 1,400. The total time was 20 minutes. You have to multiply the minutes by seconds times 60 to find seconds, and then the total distance or the total speed would be around 1.1617. You can say 1.2, which is again correct. 1.17 or 1.2, they are correct. Okay. Now, moving on to the next question. A student wants to measure the diameter of a wire. The wire is thinner than a single graduation on her ruler. Wire is very thin. She coils the wire carefully and makes 12 loops as shown. These are 12 loops of the wire. Describe how can she use her ruler to determine the diameter of the wire accurately. You may draw on figure 2.1 as part of your answer. So how can she find the diameter? Okay, so you need to put the ruler on top of the coil and measure the total thickness of the coil. Right? total thickness of the coil. So it's 12, right? So put the ruler, put the ruler on top of the coil, measure the total thickness, measure the total thickness of the coil, and then divide the total thickness, divide the total thickness by divide the total thickness by the number of coils, or by the number which is 12. Since he took the 12 loops, then you can divide by 12. Okay, to find the diameter, of the coil, or of the wire. Student determines the density of the metal wire. She folds some of the wire into a small shape as shown in figure 2.2. She then puts the small shape into a measuring cylinder containing water. The measuring cylinder is on an electric balance. The procedure is shown in 2.3. You have the electric balance. The mass. Can I find the mass of the wire? Okay, this is easy. The mass would be the difference between them. 112 minus 67. Yes, 112 minus 67, which is, yes, 45 grams. Can I find the volume of the wire? Yes, I can find the volume of the wire. V2 minus V1, which is 32 minus 27. 32 minus 27. 5 centimeters cubed. Can I find the density? Yes, I definitely can find the density equals mass over volume. The mass is 45 and the density and the volume is 5. So this would give you a density of 9 grams per centimeters cubed. 9 grams per centimeter cubed. Okay. Car has a fault. Okay. Is this actually 45? Mass of the wire, 112 minus 67 is, let me calculate it again. I guess, yes, it is 45. Did I do something wrong? 112 minus 67. Yes, it is 45. So 45 divided by 9 divided by 5 is, uh, oh, we're talking about a different wire. Okay, thank you. Yes, yes, we are talking about a different wire. So the mass is 64 and the volume is 7.2. I did not read that well. This is quite a common error, actually. You need to read the questions quite carefully. Okay. Car has a fault. Mechanic uses a machine to pull the car onto a recovery vehicle as shown. And then figure 3.2 shows how the mechanic applies a force to the handle of the machine. Can I find the moment? Yes, you can find the moment. Moment equals mass equals force times perpendicular distance. Moment equals force times perpendicular distance. What is the force? 26 newtons, and the perpendicular distance is 0.94. So the total moment would be 24.44, or you can just write it as 24 newtons dot meter. Describe one way the mechanic can increase the moment of the 26 Newton force about the pivot. How can I increase the moment? You have the same force, 26 newtons. How can you increase the moment? Increase the distance. Yes, thank you. Increase the perpendicular distance between the pivot and the force. Not closer. No, no, no. Closer is wrong. Okay, increase. Okay, increase the distance from the pivot. The car is lifted vertically 0.78 meters onto the recovery vehicle. The weight is 14,000 newtons. Calculate the minimum work done. What would the work done be? How can I find the work done? Work done equals what? Force times distance moved, not force times perpendicular distance. Force times distance moved. So it's 14,000. The force, which is the weight, times the distance moved, 0.78. 14,000 times 0.78, which is 10,920, or you can write it down as 11,000 newtons dot meters. For the previous question, can I say force? No, you cannot increase the force. Why? Because he's saying how can he increase the moment of this force, of this specific force? So the force is constant. You cannot increase the force for this question. So the only way to increase the moment would be by increasing the distance, and definitely the work done. The unit of the work done is in joules. Hmm. Okay, energy stored in water behind the hydroelectric dams is an example of renewable. State what is meant by a renewable source. Yes, doesn't run out. Yes, doesn't run out. State the name of one other renewable resource. Any other, huh? Okay. Solar cells, solar energy, geothermal, nuclear energy store. It is divided into several things. Electrical working, and then you have some kinetic energy, and then some thermal energy. From this information, calculate the percentage of the energy wasted to thermal and kinetic energy. Yes, we can see it is 65. Why? Because kinetic and thermal would be 15 plus 50, which is 65%. Can I find the percentage of the electrical working? Yes, if the total input was 100%, total output has to also be 100%. If this is 65, so this has to be 35. 100 minus 65 would be 35%. Electrical power is also generated from the water behind the hydroelectric dams. State two disadvantages of generating electricity from the water behind disadvantages of hydroelectric dams. Yeah. What can we say? We can say it causes flooding behind the dam. It destroys the animal habitat. Okay, destroys animal habitat. It causes flooding. Okay, causes flooding behind the dam. Okay, a sealed glass bottle contains air. The temperature is 21 degrees Celsius. Can I convert from Celsius to Kelvin? Yes, I can convert from Celsius to Kelvin. Okay, it's one of the newer questions which was added to the syllabus quite recently. So converting from Celsius to Kelvin, you just need to add 273. Kelvin equals Celsius plus 273. So basically 21 plus 273 is 294. Okay, 294. The temperature of the air in the bottle decreases to 14 degrees Celsius. State and explain what happens to the pressure inside the bottle. Use your ideas about gas particles. Gas particles. What happens to the pressure? So we have a sealed container, which means that the volume is constant. The volume is constant. When it decreases, when the temperature initially was 21 and it decreases to 14 degrees Celsius, what happens to the kinetic energy? Think about the kinetic energy. First of all, you think about the kinetic energy. So you have to say that the kinetic energy decreases. So the molecules are moving slower. Kinetic energy of the molecules decreases. Molecules move slower, hit the walls with less force. With less force, right? They hit the walls with less force, not as strong. And then when they hit the walls with less force, what happens? And less frequently. And less frequently, not as much because they're moving a lot slower. So what happens to pressure? So pressure eventually decreases. Why? Because pressure equals force over area. So if you decrease the force, you're also decreasing the pressure, right? Hmm. Okay. Yeah. Figure 6.1 shows a wood burner in a cabin. The wood burner keeps the inside of the cabin warm when it is cold outside. Explain how thermal energy from the wood burner warms the cabin by convection. Use your ideas about density. Basically, we need to talk about convection. What happens during the convection? Think about it. Convection, as the molecules get heated up, what happens? So, as the air gets warmer, what happens to volume? Yes, volume increases. As the air gets warmer, hmm, the volume increases. So the density, hmm, you have to talk about the density. Density decreases. Hot air hmm, rises up, and cold air falls down. And cold air hmm, falls down. Okay, all good? Yeah. The outer surface of the chimney is dull and black. Explain how the dull black surface helps to warm the cabin. If the outer surface of the chimney is dull and black, what is good about the dull and black? It's the better what? Ah, if the outer surface of the chimney, here's the chimney, okay, it's still inside the room. Ah, it's still inside the room. It's the best or is it the worst? Yes, it is the best. So it's the best emitter or absorber? That's the question. Is it the best emitter or absorber? Huh? For this question, actually, it is the best emitter. Why is it the best emitter? Best emitter. Hmm. Let's think about it. In the room, the guy is sitting next to the chimney. So if the chimney is dull black, if the chimney is dull black. If it is a best emitter, then that means that it is emitting most of the heat inside, which is okay for the man because he needs to warm up. It's cold outside, so he needs to warm up. So the black in this case is the best emitter of what? Emitter of what? Because you cannot say it's the best emitter of heat. No, that's wrong. We've always said the best emitter, best absorber, worst emitter, worst absorber of infrared radiation. Of infrared, radiation. You have to say it. You must say best emitter, best absorber, worst emitter, worst absorber. Of what? Of infrared radiation. Okay? Hmm. Now, Why should I say emitter and not absorber? Because this chimney is now hotter. Okay, the chimney is now hotter than the surroundings. It's hotter than the room. So if it is hotter than the room, for example, I have a cup of coffee. Okay, I have a cup of coffee. So this cup of coffee is now hotter than the surroundings. So this cup of coffee is emitting. It is emitting infrared radiation. Sunlight has nothing to do with no sunlight has nothing to do with the chimney. Why? Because you're burning wood inside the burner, so the heat is leaving the burner through the chimney, and the chimney can give off some of the heat. Okay. There is a shiny foil on the wall. Shiny foil on the wall. Okay, can you see the shiny foil behind the chimney? Explain how the shiny foil helps to warm the cabin. So if it is shiny, how does this help? If it is shiny, how does it help? Shiny surfaces are the what? You might say the worst emitters, the worst absorbers, and best what? In this case, they are the best reflectors. They are the best reflectors again of infrared radiation. So best reflectors, they are, I know they are the worst emitters and they are the worst absorbers, but they are in this case the best reflectors of infrared radiation. Infrared, radiation. Why is this good for the man? Because you have some of the heat being radiated. Some of the heat will hit the walls. If you have a shiny foil, so this heat that hits the wall will be reflected back to the room, reflected back to the man, to all, okay, to the whole room. So this is why a shiny foil behind the burner would be a good practice. Why? Because it would reflect most of the heat back into the room, while the chimney, okay, it's made out of or it is painted dull black. Why dull black? Because dull black would be the best emitter because it's hot, so it emits. So the shiny white is shiny. Why is it the shiny foil is shiny? Why? Because it reflects the infrared radiation. Okay. Hmm. The direction of vibration in a type of wave is parallel to the direction. So the vibration is parallel. What is this wave called? If they are parallel, what do we call these waves? What do we call these waves? Do we call them longitudinal? Longitudinal. 7.1 represents a ripple tank showing diffraction. The ripple tank is viewed from above. The waves are moving from left until they reach the barrier. You have a wave, you have a barrier with a narrow gap. How can I draw the waves as they pass through the narrow gap? When they pass through the narrow gap, you need to use a compass. Okay, pointy edge should be in the center of this gap. Open up the compass to the first wavefront and draw a semicircle on the other side, and then open up the compass to the second wavefront and draw another semicircle on the other side. Okay, and repeat for the third one. Draw another semicircle on the other side. So now we have three wavefronts. Okay, indicate and label one wavelength. One wavelength would be either on the left hand side or on the right hand side. They're both right. But one wavelength would be the distance between two wavefronts. This is one wavelength, right? Okay. Now we have drawn the diffraction, the wave. Okay. How can we draw it? Again, how can we draw it? Using a compass. Okay, the compass has to be in the center. You have the pointy edge of the compass and then you have the pencil, right? So the pointy edge has to be in the center, exactly. Open up the pointy edge to the first wavefront and then draw it on this side. And then on the second one and draw it on this side. Third one and draw it on this side. This is how you draw the semicircular waves. Can I find the frequency if I have the wavelength and the speed? Yes, it's called diffraction. Yes. Can I find the frequency? Yes, I can find the frequency. Frequency equals speed over wavelength. Hmm. The speed is 38 centimeters per second, and the wavelength is 4.6. 38 divided by 4.6 is 8.3 hertz. 8.3 hertz. Yeah. Now, figure 8.1 presents charging. You have a dry cloth and you have a strip. The student charges the acetate strip by using the dry cloth. Explain how it becomes positively charged. Due to this friction, it loses electrons to the cloth. Okay? So by friction, it loses electrons to the cloth. Okay? Now, he has two of them, okay, to the cloth from the rod, from friction. Yes, yes. Describe and explain what happens when the two positively charged strips are close to each other. What happens? This is repulsion. Why? Because they have the same charge. Okay? Repulsion, because they have the same charge. Same charges repel. What are the 3 marks for the last question? You had 3 marks, so friction, 1 mark, loses electrons, second mark, to the cloth, third mark. And here repulsion because they are the same charge. State 2 ways of making the coil rotate faster. How can I spin the coil faster? You have 3 ways actually. Two of them would be increasing the current, increasing the number of turns, and increasing the strength of the magnetic field. Yes. Increase the current, increase strength of the magnetic field, or increasing the number of turns. Okay. Figure 9.2 shows an electric fan. You have a transformer. The motor requires 120 volts. The mains is 220 volts. 220 output 120, primary coil 800. Can I find the secondary coil? Yes. VP over NP equals VS over NS. You have two of them. What should you do? Or you have three of them. Yeah, 220 over 800 equals 120 over NS. Cross multiply. Using the cross multiplication, you'd find that the output would be, or the number of turns on the output would be 440. Yeah. A plug connects the transformer to a main supply. There's a fuse in the plug. Describe how the fuse works. How does any fuse work? Think about it. How does any fuse work? When you have a very large current, what happens to the fuse? It melts. Why? To prevent any damage from happening to the device. Okay, fuse melts when the current increases. When the current increases, to protect the device from overheating. From overheating. Hell. Okay, cross multiplication. Okay, yeah. Name 3 types of nuclear emission. What are the 3 types of nuclear emission we know of? Okay, alpha, beta, and gamma. Alpha particles, beta particles, and gamma. State the type of nuclear emission which has a relative charge of positive 2. Alpha. Nuclear emission which is part of the electromagnetic spectrum. Gamma. That is easy. The isotope. Okay. Decays. Okay. The half-life of the titanium is 6 hours. Determine the fraction remaining in a sample after 18 hours. Okay. That's not hard. Positive 2. Alpha has a charge of positive. Alpha is positively charged. After 18 hours. And the half-life is 6 hours. How many half-lives do we have in 18 hours? So 18 divided by 6 is what? Is 3 half lives. What do I mean by 3 half-lives? So basically you are dividing by 2. Dividing by 2, how many times? 3 times. So divide by 2, how many times? 3 times. So basically you're halving it. So half and another half and another half. You have 3 halves. So 3 halves. So divide by 2, divide by 2, divide by 2, which would be 1 over 8. So this is the remaining fraction. This is the remaining fraction because you divided by 2. How many times? 3 times. Okay? Yeah. You divide whatever. You don't need to divide something by 2. You can divide 1, for example, if you want to use the calculator and say 1 divided by 2, and then divide by 2, and then divide by 2 again. It would give you again 1 over 8, which is basically the same thing. You're having it 3 times. Okay, how many electrons, how many neutrons, and how many protons do we have? Number of electrons, 43. Number of neutrons, 99 minus 43, which is 56. Number of protons is again 43. That was easy, wasn't it? Space physics. We have a solar system, our very own solar system. What is planet X? Mercury, then something, then Earth. Mercury, Venus. And then you have Earth, Mars, Jupiter, Saturn. What is planet Y? Yes, it is Uranus. Excellent. Mercury is nearer to the Sun than Jupiter. State 2 other ways in which Mercury is different from Jupiter. Mercury is different from Jupiter. 2 other ways, which are, it's quite close. So, smaller. Yes, excellent. What else? Smaller and the structure. What is the structure? That is okay. What about the structure of Mercury compared to Jupiter? So Mercury, first group. What do I mean by first group? It is rocky. Yes. So Mercury is smaller. Okay, you can say Mercury. Mercury is smaller, and Mercury is also rocky. Yes, excellent. Mercury has a weaker gravity than Jupiter. You're not wrong. Okay, you are not wrong, but this isn't a definitive property of Mercury. It's not a definitive property of Mercury. When talking about Mercury, we need to talk about how large is it? It's quite small, and about the structure, which is that it is rocky. Jupiter is a gaseous planet. Jupiter is a gaseous planet. The accretion model states that the solar system was formed from clouds and dust and from clouds of dust and what? Clouds of dust and gases, which contained hydrogen, yes. It contained a lot of hydrogen, yes. The material of the solar system was pulled together. Anything can get pulled together. Any two things can get pulled together in space by, yes, by gravity. Thank you. By gravity. Yes. The galaxy that includes the solar system, our very own galaxy, is called what? Is called the, yes, Milky Way. Excellent. Now, complete the following statements by adding the missing units. The Earth orbits the Sun. Okay? Earth orbits the Sun in approximately 365 days. The Moon orbits the Sun. Orbits the Earth, I'm sorry. In approximately one. Approximately one. The Moon orbits the Earth in approximately 1 month. Yes, one. The diameter of the Milky Way is approximately 100,000 light years. Thank you. Light years. Excellent.